Hello everyone, welcome to the ITLS Academy. Today we are going to discuss the topic that is your refining of sugar. Okay, so first of all, refining of sugar, um, we all know that when we get a raw sugar, then this raw sugar are in the color ranges light to dark brown. Okay, this raw sugar are in the range of color that is your light to dark brown, and they are also slightly sticky, and it contain around 1 to 2% of the ash, starch and coloring matter. Okay, so this raw sugar contain ash, starch and coloring matter. And the percentage of this ash, starch and coloring matter is around 1 to 2%. Okay, the purpose of the refining raw sugar so that we remove the impurities which are present into it. Main purpose of the refining the sugar is what? We have to remove the impurities present into a raw sugar. We have to remove the impurities present into a raw sugar. Now, it will produce a refined sugar of nearly 100% purity. Okay, when we remove the impurities present into it, then it will produce around 100% purity refined sugar, and there are several stages in the refining procedure, and each certain number of impurities and color is removed. So when we are refining the sugar, so there are several steps or stages for performing the refining process, and it will remove a certain number of the impurities and the color, and the several steps of the raw sugar refining are described in the following slides. So the first is your principal step in refining of raw sugar. Okay, so the first one is this is your raw sugar. It will go into a mignon and the affination. So all the step will be discussed in the later slides. Here I am going to give you a quick re, uh, quick uh, quick thing about the refining of the sugar, and I'm going to tell you the principle of the step which are required for the refining of the sugar. Now this raw sugar, first of all, they go into a migler and the affination. Then as a raw form, it will go into a melter. Then it will go into a clarification in the form of liquid 70%, and here phosphatation and carbonation are occurred, then filtration, then decolorization, then vacuum crystallization, in which we get a refined white and brown sugar, and also we get a molasses and the syrup. During the decolorization, there is a granule carbon bone charcoal ion exchange resin take place. So this is the figure which represent the principal step which are involved in the refining of the raw sugar. Now we are going to discuss one by one. The first one is your affiliation. Okay, so the first step for the refining of the sugar is the affination. The first step in refining is removing the adhering film of molasses from the crystal of raw sugar. Okay, suppose that this is a crystals of the raw sugar. Now it contain a adhering film of, like this, suppose that adhering film of molasses. They are what? They are considered as a molasses. Now this molasses which are adhere into the raw sugar, they can be removed by the process that is called a washing. Okay, and the process is known as a affination. So simply affination are defined as a removing the adhering film which are present in the form of molasses present into a crystal raw sugar, and it can be removed by the method that is called by the process that is called a washing, and the method is known as a affination. Okay, so this is done by mingling the raw sugar with the hot raw syrup in a large throw are containing a mixel paddle and a scroll and the raw syrup which has dissolved some of the adherent molasses film from the crystal face. Now what we do, we use a raw sugar with the hot raw syrup in a large straw which also contain a mixel paddle and scroll. This raw syrup dissolve all the adherent molasses film which are present into a crystal, is spun off, and the residual sugar is washed with a jet of the hot water so that it will remove the residual syrup. The affination process yield a pale colored sugar which is discharged by our bullocks into a continuous melter tank. Okay. Now the next is your melting. Then the raw sugar. See, now this sugar are what? They are washed sugar in which the film of the molasses are removed. Now this is melted into a hot water in a melted tank where it meets a stream of hot sweet water from the process. Now this dark brown sugar liquor which are coming from the melter are adjusted to a density about 65-degree Brix, and the melter liquor is strained through a plain screen so that all the insoluble debris which are present into the melted liquor are removed. Okay, so this is a step of the melting. Now the next step is your clarification, then raw wash sugar liquid. Now in case of the affiliation, the raw sugar are called a wash raw sugar, but when this raw wash sugar are come out from the melting, then it will convert it into a raw wash sugar liquor which are come from the melter. It contain a particulate matter, and this particulate matter are come from a different sources. Okay, this raw wash sugar contain a particulate matter. Now this particulate matter are come from a different sources, that is your field soil, fiber, yeast, mold, gums, colloids, and foreign contaminant. So the main object of this clarification is that simply remove the all undesirable component, and this removal is complete removal. Now the raw liquid is also acidic. One of three processes then used: carbonation, phosphatation, or filtration. Because this raw liquid is what? They are acidic in nature. That's why we use either carbonation, phosphatation, or filtration method. Now, carbonation and phosphatation are chemical treatment process which form a precipitate inside the liquor, and the filtration paper is what? It is like use a filter membrane so that it will not allow the some particle to grow or to go inside it. Okay, carbonation and phosphatation are a chemical process which form a precipitate, and in by the use of filtration what we have to do, we permit the movement of the some particle, we hold it inside the filter paper. The carbonation process is similar to that used in a purification of the juice for a raw sugar, which processing except for high liquid density which is compared to the juice in the cane. Process involve two stages. See, this carbonation process are very similar, which we already discussed in a previous lecture, that is your purification of the juice from the raw sugar. Okay, but here the exception is that we have a high liquid density. We have a high liquid density as compared to the juice in the cane, and this carbonation process are involved two process, or you can say that two stages. In the first stage, the high density liquor are heated at 60 to 80 degrees Celsius in a saturated tank and is limed to about pH 10. Okay, now in the first stage, what we have to do, we have high liquor, a high density liquor which are heated at 60 to 80 degrees Celsius inside the saturated tank, and then it is limed to about pH 10, and then carbon dioxide from a flue is bubbled through the limed liquor. Okay, now what we have to do, we add a carbon dioxide in the form of the bubble inside the lime liquid until its pH is dropped from 8.4 and 9. When we added the lime, its pHs are reached to the 10. That's why we are going to add a carbon dioxide in the form of the bubble so that its pH are dropped from 8.4 to 9. When it is dropped, then we will stop it. Now, several saturation tanks are used during the processing. A voluminous and gelatinous precipitate of calcium carbonate along with the co-precipitate salt interrupted and color bodies are formed. Okay, in the second stage, what we have to do, the precipitate which are formed in the first stage is conditioner so that it will improve the filter ability. Now this precipitate are carried out with the most of the coloring matter which are present, and it is removed by the method that is called a filtration method. In phosphotation, what we have to do, we use a high density liquid. What we have to do, we have a high density liquid. Now it will be heated at the temperature range around 60 to uh, 60 to 70 degrees Celsius. After that, we treat it with the phosphoric acid, but the amount of phosphoric acid is very small, and sufficient amount of milk are added of a lime so that the temperature are so that it bring the pH of that sample is around 7.2 to 7.8 degrees Celsius. After the addition of the lime, the liquid temperature raised 90 degrees Celsius and the time is allowed for flue formation. Some air are injected into the sample system so that it will interrupt the air bubble into the flue. The precipitate then float to the surface as a scum and scrap off without any filtration. The phosphate clarify have many sizes and shape. Essentially, all present day systems are based on a Williamson pattern of 1918 in which the liquid are impregnated with air, then it will heated in a suitable vessel so that the insoluble material float and it does not depend upon the filtration. Some of the best known clarifier are Williamson, Bulky Dunton, Seven Pedersen and tallow clarification system. Now the next is your filtration method. Filtration method is simply the most straightforward method, probably the oldest method for form of sugar liquor clarification process. Filtration is affected with the plate and frame pressure filter or some type of the leaf pressure filter, that is your Sweetland filter with a stationary suspended circular leaf which are covered on both sided with the filter cloth. Filter add of some sort, that is your diatomous earth, paper pulp or kesselgar is very essential for this operation. Now the next method is your decolorization. The clarified liquor, although brightly clear of the contaminant, is very dark brown in color. Colorant may originate from a plant pigment which have remained in a sugar solution and may be resulted from the reaction of the ammonia acid as reducing sugar. or caramel resulting from a thermal decomposition of the sucrose or reducing sugar. So some degree of the decolorization are occur in every step, that is your refining, but the color is being processed especially in hot concentrate liquid. So the decolorization is therefore a very important step, because there is a present of the coloring agent in the sucrose, which are highly objectable in the use of product in a food manufacturing. Okay, so what we have to do, we although we remove all the contaminants, but the dark brown color of the sugar are also there, although in some point of view it will reduce, but the concentration remains same. So this color may have a impact inside the food manufacturing, or maybe sometime it will be objectable for the production of the product with inside the food manufacturing, so that the process decolorization will be done, so that it will remove the color of the product. The color has an aesthetic appeal for the consumer and is the main property that distinguishes refined sugar from the raw sugar. Okay, so this decolorization is the main process which differentiate between the refined sugar and the raw sugar, because the raw sugar are brown in color, but when it is decolorized or when we refine it, or and it will reaches to the decolorization step, then in that case the refined sugar are converted into a white crystal form. Now the next is your carbon absorbent have traditionally been used for the removal of the coloration. Okay, so we use a carbon as a adsorbent. Now what does carbon do? They absorb the color of the raw sugar and clarify it. The general carbon adsorbent, which may be bone char, granule carbon, or powder carbon product, they are used in either a fixed bed operation or moving bed process. These carbon are regenerated at different intervals so that it will maintain their effectiveness. Now, the use of ion exchange for the decolorization is also more widely applied uh, for the refining of the sugar nowadays. Now, the chloride form of the strong anionic resin is also used for the decolorization of the liquor, and the sodium form of strong cation resin softens the liquor. Okay, so anionic resin they decolorize the liquor, and the sodium form of the strong cationic resin they soften the liquor. There is a significant advantages of ion exchange are in situ regeneration without the heat, without the use of the heat, short contact time, and small size of the equipment. Now the next is your crystallization and the finishing. After the decolorization liquid, it goes into the next step, that is called a crystallization and the finishing process, which are range from a water that is white to pale yellow with a solid content around 50 to 65 degrees Celsius. In many refining, the liquid are further polished, filtered, so that it will make sure that it is sparkling clear with no turbidity. In many cases, the liquid is pre-evaporated so that it will reaches to the bricks to less than 68, that is 68%. The evaporated liquid is then drawn into a vacuum pan in which the massicute is boiled, and the vacuum pan are the calandria type, just as those prescribed earlier under the raw sugar manufacture, and their operation is the same. The control crystallization of the sugar so that it will produces the various size of the crystal is a complex process which are totally depend upon the boiling rate throughout the proper seeding. The proper moment for seeding is determined by the instrument that is called a stretching a string of evaporated liquor between the thumb and the index finger, approximately 4 to 5 centimeter, without breaking down. The seed is finely pulverized sugar. It will disperse into a isopropyl alcohol or a sugar liquor. Addition, the seed are induces an immediate formation of the crystal nuclei throughout the supersaturated syrup. Once these nuclei are grown to a significant grain size, the rapid crystallization are occur and the process is known as a strike take place. Ordinarily, 3, 4 or 5 strike of refined sugar are obtained, and the syrup from the fourth strike are sent back to the decolorization and the recycled. Then the recrystallized sugar is transferred to a centrifuge so that it will remove the free liquor, and the sugar from the centrifuge contain about 1% of the moisture. Then it will go to the conveyor so that it will hold the bins which are located just above the dryer. And this dryer are called a granulated because they rotate and keep the crystal from sticking together. Okay, the dryer which are present in just above the holding beans, they are rotating, and when they are rotating they keep the crystal uh, from sticking together and thereby keeping them granule. The final handling step is packaging and the storing, and the granulated sugar are stored into a cellulose beans bag which are made from a paper, jute or plastic, and the unbagged loose or bulk sugar are distributed to the wholesaler in beans or trucks or rail freight or cars. So this is all about the refining of the sugar. I hope you will understand all the steps which are related to the refining of the sugar and other thing. But if you have any query related to this topic, you can ask me in a comment box, or for a further detail, you can follow the ITLS Academy on different platforms, that is Instagram, Facebook, Twitter, YouTube, WhatsApp and LinkedIn, and subscribe our channel ITLS Academy on YouTube and get our app from a Google Play. You can also ask your query to the helpline number that are already mentioned in your slide, that is 7080833450, and visit our website www.itlsacademy.com. Thank you for watching. Please like, share and subscribe our channel.